All right, here's our lesson video for Unit 8, Day 4, or Day 8.4. We are talking about parabolas in the coordinate plane. Now, this is going to seem very new to a lot of you. You might recognize certain aspects of this lesson from Algebra 1, but a lot of this is going to be very, very new. Even in this unit, it's going to be not a whole lot like anything else we've been doing this unit other than working with the coordinate plane. So we're going to talk first about kind of what a general graph of a parabola looks like. This comes from a specific kind of function or a specific kind of equation in algebra in the coordinate plane that we call quadratics. Okay, a quadratic function has a graph shape that is called a parabola. So something that looks like this, a U-shaped curve, could open up like that, or down like that. All right, a U-shaped curve. Okay, and it usually comes from something we call a quadratic formula or quadratic equation. This is what we would call standard form. Okay, but we are using a form today called vertex form. And here's what the equation looks like in vertex form. Y equals a parentheses x minus h parentheses squared plus k. And you might recognize this form from Algebra 1. Okay, but a, h, and k are all going to be replaced by numbers, and they all mean something specific to parabolas. And so we've really got two different cases to look at here. We have the case of what we call opening up, direction of opening being up, or direction of opening being down. And then we've got some new words here. Vertex, we've talked about what a vertex is before, but these two words here, focus and directrix, are specific parts of a parabola scenario or a parabola type equation and graph that are going to be important in this lesson. So we're going to take a look at what those things are. So what I want you to do, I'm going to put some images up here alongside each of these. And I want you to pause the video and copy them down. Actually, just do one of these at a time and then continue to watch the video as I explain what the pieces are, and then pause to copy the next one down and go from there. So here's what your first graph here next to the opening up, direction of opening up, is going to look like this. Okay, pause this video to copy this down. Make sure that this dot here, what I've marked as my red dot, is the same distance from your point here at the very bottommost part of our parabola, we call that the vertex, as the distance from that parabola point vertex is to this line. Okay, we want to keep those distances the same. All right, if you have this drawn on your paper, this is kind of what this is going to mean. Now, the parabola itself is this curve. This point here, the maximum or minimum, it's a minimum in this case, the point where my parabola changes direction, is called the vertex. All right. That point is called the vertex. It's the change in direction point. Then this point inside my parabola is called the focus. That point inside the parabola is called the focus. And finally, this line underneath this parabola is called the directrix. All right? Now, those are very, very key parts of what we're going to be doing today. Just remember this. The directrix is a line. In fact, it's a horizontal line. In fact, write that underneath directrix. Horizontal line. It has to be a horizontal line, and from the beginning of our lessons here, we noticed that horizontal lines are always in the form y equals a number. And so we're going to talk about what those are in just a moment. Okay, this point of the focus is always an ordered pair. Okay, focus and directrix are always ordered pairs, x comma y. Sorry, focus and vertex are always ordered pairs, x comma y. And so it's going to look like that if we have an opening up situation. Well, our picture for opening down looks pretty similar to this, just exactly upside down. In fact, I could just take this and turn it, and this is what it would look like for opening down. So I'm actually going to redo this over on this side. Okay, and so when we have a parabola that opens down, it's going to look like this. Okay, we're on our parabola. This is our vertex. This is our focus. And then our directrix is now above the parabola. So we're going to look at different cases like this, and there's a way that we can tell from our equation which version of this one we're using. But there's one more piece I want to give you here. Okay, when we look at, let's just look at the opening up scenario. When I'm looking here at this kind of a function, what we have is the reason for a focus and a directrix actually gives us a clearly defined form of this line, where the distance from any point on my parabola to the focus, so the distance of those values is always the same as the distance of that point to your directrix. Now, I've not drawn this very well to scale. They look like a lot smaller, or this looks like a lot smaller than that. But these will always be the same distance, and that is most clearly seen in this most shortest distance. We call this distance from focus to vertex point P, and it's these, or value P. And it's the same as the distance from vertex to directrix. And so that's going to help us here over on this side. The distance from focus to vertex is P, and the distance from vertex to directrix is that same value P. Now, I haven't drawn it to scale very well, but those are supposed to be the same distance. And so we're going to take a look at applying this to some equation parts. Okay, so in this vertex form, all right, the direction of opening can be figured out all based on A. If A is greater than 0, meaning A is positive, all right, that means that we open up. Okay, if A is positive, we open up like that. Looks like this one. If A is negative, less than 0, that means we open down, like this one. Okay, so the direction of opening is figured out all based on what A is. Now, A is actually a calculation. A is something else that we can calculate, and this is the formula for calculating A, 1 over 4 times P. We just talked about what P was. So if I'm given a formula with A, I can solve that equation for P to figure out what that distance is, because that's going to help me figure out vertex, focus, and directrix. In fact, our formula here for equation of a quadratic or equation of a parabola in vertex form tells me what our vertex is actually. The vertex of a parabola is always the ordered pair h, comma, k. Now, because of this minus sign here, there's a saying I want you to write. I want you to write this phrase: H lies, K tells the truth. Okay? Because of this minus sign, when we figure out our vertex point, we always want the opposite of whatever we see here. If it's a minus, H is positive. If it's a plus, H is negative. But K always tells the truth. So whatever sign you're given for K, plus K would give a positive K, and minus K would give a negative K. And then from that, the rest of this determines, or is determined by P. Remember, the focus is a point with an ordered pair. What you notice is that it's always lined up vertically with your vertex. So the focus coordinates share the same x value, h. But to find the new y value, we're going to take whatever our p value was here, and we're going to add that to k. So we take our k value and we go up by p, so we add p. All right? But the directrix is also based off of that. But the directrix is always a horizontal line that is just y equals whatever that k value was minus that p value. This will work whether it opens up or down. Here's all you need to remember. If this opens up, a is negative, so when you solve this, p is negative. Okay? Sorry. If a is positive, p is positive. If a is negative, p is negative. Okay? And so we can do some examples that show us how to calculate these things. We're going to do one example here, and then we'll do the rest in class. So we're going to do this first example. We are given an equation in vertex form, and then we are told to state the direction of opening, the vertex, focus, and directrix, just like was labeled above. So we're going to write those down. Direction of opening, okay, D of O, direction of opening. Vertex, we can use abbreviations or initials. Focus, and directrix. So those are the things we're going to identify from this equation. Okay? So remember, our direction of opening is all based on the a value. Is it positive or negative? So our direction of opening for this first example is based on the fact that a is positive 4. Okay? Sorry about that. A is positive 4, so the direction of opening is up. And that's going to make a difference as we go through our problem. Then I want to look at the vertex. All we have to remember is h and k, but h lies, k tells the truth. So my vertex is actually at positive 2, 1. So that's my vertex. My focus is based on that vertex. My focus is k plus p for the y value, but the h stays the same. So this x-coordinate for my vertex is also the x-coordinate of my focus. But then, to figure out what this y value is for the focus, we have to know what p is, because I have to do k plus p. So this is where we kind of pause for a moment and we evaluate what p is, remembering this formula. A equals 1 over 4p. Well, if a is 4, I can put that in here, but let me give you a little bit of a shortcut. If a equals 1 over 4p, guess what? If I were to solve this equation for p with a still there, it actually works out where p is also 1 over 4a. I can replace and switch them out. And I'll show you in class how I got that. So I'm actually going to use that, because I have a already, and it'd be nice just to plug it in and not have to work backwards. So p then is equal to 1 over 4 times the a value of 4. Well, this is 1/16. So we have a fractional value of p, and that's going to be the case for most of our problems here. So what I want you to remember, that finding our focus, remember, it's h, k plus p. It's a positive, so I'm going above it. Okay, that makes sense, right? If I were to draw this out, it opens up. There's my directrix, but here's my focus. So to go from vertex up to that point of my focus, I have to increase, I have to add. So I'm going to take that k value of 1, and I'm going to add my p value of 1/16. Well, just think of writing that as a mixed number, 1 and 1/16, and so we can leave it written that way. No decimals needed, no calculators needed, just write it as 1 and 1/16. And then finally, to find the directrix, all you have to do is write an equation, y equals k minus p. Well, let's simplify that. For our directrix, we say y equals, our k value, go back up here, was 1. We're going to subtract my 1/16 that I found for p. Well, think about what 1 is as a fraction over 16. Well, that's 16 over 16, right? 16/16 is a whole number 1, and I'm going to subtract 1/16. So I'm doing 1/16 less than a whole number, which makes it 15/16. And so that is your directrix line, y equals 15/16. We're going to do some more examples. We are going to use fractions, but this gets us at least a starting point for this lesson.